Hi, this is King of Review. Find a range of the common ratio if the following infinite geometric sequence is convergent. 1, negative 2r, 4r squared, negative 8r to the third, and the sequence continues. We're told we have a geometric sequence. A geometric sequence is a list of numbers or terms where the ratio of any term to the previous term is constant. Therefore, it has a common ratio. This is also an infinite sequence that's represented by these dots here. An infinite geometric series has infinitely many terms, yet it has a finite sum. And the last bit of information we're told about this sequence is that it's convergent. What does this mean? Well, a sequence can be either convergent or divergent. If it's convergent, this series has a finite sum. But if it's divergent, the sum approaches or goes to infinity or negative infinity. Each of these type of series has a condition that must be met. For a convergent series, the absolute value of r must be less than 1. But for a divergent series, the absolute value of r must be greater than or equal to 1. For the absolute value of r is less than 1, this can be written as r is less than 1 and r is greater than negative 1. Why is this? Well, if you think about a number line, here's 0, here's 1, here's negative 1. The absolute value represents the distance from 0. So it must be less than 1, but if r is negative 1, the absolute value of negative 1 is 1. So this is what it would look like here. And how do we represent this? R is less than 1 and r is greater than negative 1. And when you put these two together, we get negative 1 is less than r and r is less than 1. So this is the condition that must be met for a series to be convergent. Let's quickly graph a series that's convergent and one that's divergent so you can see what we mean here. So we have our x-axis and our y-axis. X is going to represent n. And we know that if a series is convergent, r must be in between negative 1 and 1. So let's say that r is 1/2. So we're going to say y equals 1/2 to the nth power. This represents a series that's convergent. So if we were to graph this, one-half to the first power is 1/2. 1/2 to the second power is 1/4. 1/2 to the third power is 1/8. And 1/2 to the fourth power is 1/16. So if you connect these, you can see that this is approaching 0. So if r is any number between negative 1 and 1, and we chose 1/2, which meets this condition, then r to the n approaches 0 as n gets larger. Now let's take a look at this condition here and graph a divergent series. So the absolute value of r must be greater than or equal to 1. So let's choose a common ratio of 2. So y equals 2 to the nth power. So y equals 2 to the nth power. If n is 1, then y is 2. If n is 2, then y is 4. If n is 3, then y is 8. And if n is 4, y is 16. And when you connect these points, you can see that this is approaching infinity. So if a series diverges, then the sum goes to infinity or negative infinity. So there's not a sum for a divergent series. Again, we're dealing with a convergent series here. That's what we're told here. So we know that this condition must be met. -1 is less than r, and r is less than 1. So now let's figure out what r is for this particular sequence. How do we find r? R is equal to a term over its previous term. So you can choose a2 over a1, or you can choose a3 over a2. It doesn't matter as long as the denominator is its previous term. So for a2 over a1, we have -2r over 1, and this equals -2r. So our common ratio is -2r. Let's see what we get here. a3 over a2. a3 is 4r squared. This is divided by a2, which is -2r. And when you work this out, you get -2r, which is what we found here. So now -2r goes here into the condition for a convergent series here. So we have -1 is less than -2r, which is less than 1. So now we want r by itself here in the middle, so we're going to divide by -2 on all sides. And remember, when you multiply or divide by a negative number, it flips the inequality sign. So these are now flipped. -1 divided by -2 is 1/2, and this is r. And 1 divided by -2 is -1/2. So we have 1/2 is greater than r, and r is greater than -1/2. And this can be written as -1/2 is less than r, and r is less than 1/2. And here's our answer. Letter C is correct. Thanks for watching.